Good morning, children. Let us continue with exercise 5.1. The question is, find the relationship between a and b so that the function f defined by f of x is equal to ax plus 1, bx plus 3 for values of x less than or equal to 3, for values of x greater than 3 is continuous at x equal to 3. So that means it is given that function is continuous at x equal to 3. We are going to find the relationship between a and b. Okay, so we know that since there is splitting of the function, we have to use the definition of limit at left and right. Okay, so how is the definition? If you remember, children, we have done it this way. It is limit as x tends to 3 minus f of x is same as limit as x tends to 3 plus f of x is same as f of 3. Why we are using this definition? Because it is continuous at x equal to 3. Now what is your value? Substitute the value of the function. From left side, x less than 3, the function is ax plus 1. When it is from your right side, that means greater than 3, it is bx plus 3. Now at f of 3, what is the function f of 3? It is 3a plus 1 because x will take the value 3. Okay, now simplify this. Now put here the value. So here again it will be 3a plus 1 is equal to, you have 3b plus 3 is equal to 3a plus 1. Okay, now you have just consider this equation because first and third is same. So 3a plus 1 is equal to 3b plus 3. So you have 3a minus 3b is equal to 2. So you have a minus b is equal to 2 by 3. So whatever choice of a and b you are making, if the difference between them is 2 by 3, then your function will be continuous. So this is the condition on a and b. Alright, now the next one. For what value of lambda the function defined by f of x is equal to this is continuous at x equal to 0. So we have to find the value of lambda for which this function will be continuous at 0. And also we have to discuss about what about x equal to 1. So let's see here again, children, it is two definition. No? So let us check solution. So it should be limit as x tends to 0 plus f of x is same as limit as x tends to 0 minus f of x is same as f of 0. X tends to 0 plus means this, right? X greater than 0. So it is limit as x tends to 0 plus 4x plus 1 is equal to limit as x tends to 0 minus of f of x. 0 minus means from your right side. It is lambda x square minus 2x and it is equal to f of 0. F of 0 means here. So it is 0 minus 0 and into lambda. So answer is 0. Okay, so let's check. So what happens here, children? If you put here it is 1. If you put here it is 0, it is equal to 0. So what do I get? I check here the left limit and right limit are not same. Therefore I can say that f is not continuous at x equal to 0 because it is saying that you have to check the condition of lambda for which it is continuous. But if I use the definition of continuous, I am getting that for no value of lambda, the function is continuous because left limit and right limit is not the same. Now we have to discuss the continuity at x equal to 1. Now at x equal to 1, children, there is only one definition of your function, that is x greater than 0. So what will happen? You have to check the condition limit as x tends to 1, f of x is equal to f of 1. If this is true, then your function will be continuous. What it is? 4x plus 1. So limit as x tends to 1. This will always be true, no, children? So this is 4 into 1 plus 1, 5. This is also 5 equal to 5. So therefore I can say f is continuous at x equal to 1. But for any lambda, it is not continuous at x equal to 0. Now let's go for the third one. Determine f is defined by f of x equal to x square sine 1 by x 0, x not equal to 0 and x equal to 0. Okay, so here there is breakdown here. Okay, so children, at x not equal to 0, how is f of x? f of x is product, right? This product of two continuous functions. Yes or no? Yes or no? Yes. Why? Because x square is a polynomial function and sine is a continuous function. So product of continuous function is continuous. So f of x is product of two continuous functions. Hence f is continuous. Okay. Now what happens when x not equal to 0? Or sorry, what happens when x is equal to 0? Right, at x equal to 0, again it's a constant function, it is continuous. So your problem is when your function limit as x tends to 0, what is your behavior of f of x? Right, when it's not becoming 0. Okay, so this will be nothing but limit as x tends to 0, x square of sine 1 by x. That means it is trying to become 0 but not becoming 0. Right, so this is nothing but, children, this is limit of x square and limit of sine of 1 by x. But this is when you apply the limit here. When you apply the limit here, children, this will be 0. And this is, you know that value of mod of sine of 1 by x, right? This value is always equal to, or this is always less than or equal to 1, right? Because it always oscillates between 0 and 1. So this will be 0 and 1, right? This is the reason. So 0 into 1 is 0. Right, which is same as f of 0. So I can say f is continuous at 0, which I told you before. Okay, at x not equal to 0, it's product of continuous function. When at 0, what happens? Limit as x tends to 0, f of x is same as f of 0, so it is continuous at 0. Let's continue with the next one. Find the values of k so that the function is continuous at the indicated point. Find the values of k so that the function is continuous at the indicated point. So now your function is f of x equal to k cos x upon pi minus 2x at 3, x not equal to pi by 2, x equal to pi by 2 at x equal to pi by 2. So we are going to use the definition. Limit as x tends to pi by 2, f of x is equal to limit as x tends to pi by 2, k cos x divided by pi minus 2x. Okay, so I am going to make a substitution here. See, children, you remember you have solved this kind of problem last year in the example of limits. When you have x tends to pi by 2, when x tends to a, you can put x as a plus h. Yeah, so I'm going to write here, put x equal to pi by 2 plus h. Okay, so what will happen when x tends to pi by 2? Okay, when x becomes maximum pi by 2, your h will go to 0. Okay, so it will be limit as h tends to 0. New substitution will give you k cos pi by 2 plus h divided by pi minus 2 times x is pi by 2 plus h. So this is equal to limit as h tends to 0, k cos of pi by 2 plus h is, children, minus sin h, right, upon, now when you open this will be pi minus 2h. Pi minus pi will get cancelled. So this is minus limit as h tends to 0, not minus will keep it inside, minus k sin h upon minus 2h. Minus will get cancelled. So this will be k by 2 times limit as h tends to 0, because it has nothing to do with h, right? Sin h upon h. So this is by definition 1. So this is equal to k by 2. Now it is given that since your function f is continuous at pi by 2, children, you can say that limit as x tends to pi by 2, f of x will be same as f of pi by 2. But f of x is pi by 2 and our function's value at pi by 2 is defined as 3. So therefore value of k is nothing but 2 3s are 6. So if I take the values of k, value of k as 6 here, my function will be continuous at pi by 2. Okay. And let's do the next one. F of x is equal to kx plus 1, 3x minus 5. If x less than or equal to 5, x greater than 5 at x equal to 5. Find k if f is continuous at 5. So let's find the solution of this. Okay. So now you are given that f is continuous at x equal to 5. So I can say limit as x tends to 5 plus f of x is same as limit as x tends to 5 minus f of x same as f of 5. Okay, so x tends to 5 plus means what? 5 plus means more than 5. So limit as x tends to 5 plus of 3x minus 5 is same as limit as x tends to 5 minus of kx plus 1 is same as f of 5. What is f of 5? Put here the value of here as 5. So it will be 5k plus 1. So put here 5. It is 15 minus 5. 10 is equal to, here again it is 5k plus 1 and which is again 5k plus 1. Simplify this. So 9 is equal, 10 minus 1, just consider this. 10 minus 1, 9, 5k. So value of k is 9 by 5. So if I take my k as 9 by 5, my function will be continuous at 5. Now the next one. Show that the function f of x is cos of x square is a continuous function. Similarly, you have to show that f of x is equal to cos of mod of x is a continuous function. Surely if you see the function, children, carefully, you will see that these are not your normal trigonometric or normal polynomial function. You can see a composition hidden here. And children, if I am able to write the given function as composition of two other functions, my function will be continuous, because we have learned a result which says that composition of two continuous function is continuous. Now how did I guess it is composition functions? Yes, because I have seen here it's a combination of cos and modulus. Similarly, I can see here it's a combination of cos and a polynomial function. Generally, we write cos x sin x, no? This time it is cos of a polynomial function. So let us compose this. Okay, very easy. It's just you have to guess what functions you have to compose. Okay, so let me take f of x as cos of x square. Okay, I'm going to take let h of x is equal to cos x and g of x is equal to x square. Okay, now let me do h composite g at x. Okay, so h composite g at x will be what? H of g of x, right? So just write here, both are continuous, because if you are able to show it as equal to f of x, then composition of continuous functions are continuous, because cos x and x square are continuous. One is cos, another is a polynomial function. So it is h of x square. But h of x is what? Cos of x. So it will be cos of x square, which is equal to f of x. Therefore, f is continuous function as it is composition of two continuous functions. Okay, the next step, it is cos of mod of cos x. Okay, so let me take f of x as cos of mod of x. Okay, g of x I will take as cos of x, and h of x I will take as mod of x. Okay, so h this time g composite, see, just I have written the names other way around. Okay, so this will be g of mod of x. H, right? H of x is nothing but mod of x. So this is g of, now see children, because of this choice, what happened? Just see here, I changed the question. Okay, no problem. So this will be nothing, g of cos of this will be g of cos of mod x. So I can say this is same as f of x. Therefore, f is continuous. Because why? Because modulus is for continuous function and cos x, as it is composition of two continuous functions. If you have noted, children, I have formed a third problem here, right? My question is not this. My question is mod of cos x. Okay, so you just exchange, so you will get what you want. So let f of x equal to cos of mod x. Sorry, mod of this way, cos x. So now let h of x equal to mod x, and g of x as cos x. This time instead of g composite h, let me take h composite g of x. So this will be h of g of x. So this will be h of cos of x. So this will be mod of, because x goes to mod of x. Mod of x. Okay. So that is equal to f of x. Again same reason you can write, because f is continuous, that is composition of two continuous functions. Okay. Thank you children.